4.4 Polynomial and Rational Inequalities. In this section, we are going to be solving polynomial and rational inequalities, where in the first half of this chapter, we were looking at equations. We solved them, we graphed them. So now we're just looking at the inequalities and just the solving part. So we will not be graphing these ones. However, we will be checking on a number line. And I strongly suggest you do that because I know how lazy some of you can be and you don't like to do the checking part, the testing. But you guys. You really need to make sure you do the testing. So I'm going to just rework through these. And if you have questions, please make sure you write them down so you can ask me in class tomorrow. So we need to remember, since we are dealing with inequalities, when we have open and closed circles, because that will also help us when we're testing on the number line, if we should have an equal to or not equal to inequality in our answer. And also pay attention to the inequality that you are given. So I am given in this first one an open circle inequality. So whatever I find will not be included in a solution, but they will be a part of my solution. So I have to factor. We are going to factor all polynomials. Hopefully we are doing better with our factoring. Those of us not, this is going to be a little bit of a struggle for you today. And those might be the questions that you come in with tomorrow. So one of the things I notice here is these both have an x squared. I have an x squared and an x cubed. So the least amount, or the most I can actually take out, is an x squared. So if I take out an x squared, I am left with 1x left in the first one, minus 4. So now I just need to solve for x. So here I have x squared equals 0, so x will equal 0. And here I have x minus 4 equals 0, so x will equal 4. So now I need to set this up on a number line so I can test some values. So we did this a while back. Here's 0. Here's 4. I'm going to pick 3 numbers. I'm going to pick one on the left, one on the in the middle, and one on the right. So every section that your solutions create, you need to be testing those values. So I'm going to plug those back into my original equation. And again, this is not new, so I'm not going to spend a whole lot of time here. I'm going to use a lot of mental math. So I'm plugging in the negative 1. Negative 1 cubed is negative 1. Minus 4 times 1. So negative 1. This remains a negative because my exponent is an odd number, so it will have that negative still. But in the second one, my exponent is even, which will get rid of that negative. So please be careful. So I end up with negative 1 minus 4, which is negative 5. Is that greater than 0? Nope. So now I'm going to test the next one. So 1 cubed minus 4 times 1 squared has to be greater than 0. This is 1 minus 4, which is negative 3. Is that greater than 0? No. Then I try my last one, which is the 5. And I'm going to have 5 cubed minus 4 times 5 squared. So this is 125 minus 4 times 25. That's 100. So 25, is that greater than 0? Yes. So since that was my only yes, this one right here, and it was a open circle, put those back there. So my only yes happens at the greater than 4. So my solution is x is greater than 4. It's the only piece that worked. So we need to remember these are not like the quadratics that we were solving back in chapter 3, where it was either both on the outsides or in the middle. Please be careful, because this one in A is a cubic function, so it might be something a little bit different. So please make sure you check. All right, number 2. The first thing I notice in 2 is that this does not have 0. It's not set equal to 0 like A was. So I'm going to start by subtracting my 9x squared. X to the 4th minus 9x squared is less than 0. So now I can factor, and just like I did in A, I can take out an x squared, which leaves me with x squared minus 9. The x squared minus 9 you can factor even further. This is a difference of squares, so I have x plus 3, x minus 3. So I'm going to have x equals 0, negative 3, and 3. I'm not going to spend a whole lot of time going over some of this stuff, you guys, because it is review. So I make my number line. Here's negative 3, here's 0, here's 3. So this one I do have to test more. I have 4 sections here, so I will need to test that. I'm going to go ahead and put open circles here because my inequality was not equal to. So no shaded in circles. So I'm going to test negative 4. I'm going to test negative 1, 1, and positive 4. So I'm going to plug all this in. I'm going to plug into the one that is set to 0. That's the one that I want to work with. So negative 4 to the 4th minus 9 times negative 4 squared has to be less than 0. So I'm going to use my calculator. And please make sure you are using parentheses around your negative 4. Otherwise, you're going to get a negative answer. So this is 256. And then this is negative 9 times 16. So 9 times 16 is 144. So 256 minus 144. Is that going to be less than 0? No. Now I'm going to work on negative 1. So negative 1 to the 4th minus 9 times negative 1 squared. This is positive 1 minus 9 times positive 1. Well, 1 minus 9 is negative 8. Is that less than 0? Yes. So I'm going to mark here that the spot where negative 1 is worked. Now I'm going to continue. So now I try 1. 1 to the 4th minus 9 times 1 has to be less than 0. 1 minus 9 is less than 0. Hey, that looks just like this last one. So yes. And then the last one I need to test is positive 4. So 4 to the 4th minus 9 times 4 squared is less than 0. And this looks a lot like the first one we did with the negative 4. So 256 minus 144, is that less than 0? No. So please be careful how you write your answers. We got to go back and write our answers. We're not done yet. So our solutions took place in 2 spots, but we have open circles here. So here's my answers. So I'm going to write it out. It is from negative 3 to 0 and 0 to 3. And I'm not using brackets. I'm using parentheses. No closed circles. They're all open circles. You could also put negative 3 is less than x is less than 0. And 0 is less than x is less than 3. So either way you guys want to write this, generally you're going to see something like this in interval notation, not set notation. All right. Sorry, get the rest of the set there. All right, let's move on. That's it for the polynomials, I believe. Not too much there because, again, that should just be a lot of review from previous chapters. Now we're going to move on to the rational functions. And I'm only going to work out C and D. That's all I'm going to do. I'm not going to bother with E. So when we are solving rational functions for x, One of the things you guys need to remember from the first part of this chapter was that your x-intercepts comes from the numerator. So please be careful when you guys are going through and solving for this. When you're solving for x, only look at the numerator. This is set to 0. I only need to focus on the numerator. I don't need to focus on anything else here. So I'm going to look at this and I see, oh, x minus 3. Set it equal to 0, so x equals 3. But I also need to think about what my vertical asymptotes would be for this graph. So you do have to look at the denominator. So x cannot equal what makes the denominator 0. So I also need to look at this x plus 1. So x plus 1, set that to 0. X cannot equal negative 1. So that needs to be a number that I absolutely do not try. X cannot equal negative 1. So this is what it can't equal. Absolutely not. So when I make my number line, I have to use negative 1 and 3. You have to use the value from the numerator and you have to use the value from the denominator. The value that is coming from the denominator is your asymptote, so it automatically gets an open circle. The value from the numerator, you need to look back at the inequality from the original equation. So that one will also get an open circle. So then you guys would just need to go through and test. So negative 2, let's say 0, and let's use 4. So I'm going to plug back into the original. So this is negative 2 minus 3 over negative 2 plus 1, and it has to be greater than 0. So you really just need to pay attention to the signs here. So I will have negative 5 over negative 1. Is that greater than 0? Yes. So I'm going to mark that, and then I'm going to move on to the next one. 0 minus 3 over 0 plus 1. Let me double check. Has to be greater than 0. Negative 3 over 1, is that greater than 0? Nope, because that's going to be negative. And then I try the 4. 4 minus 3 over 4 plus 1. So this is 1 over 5, and is that greater than 0? I hope you all said yes, because it's positive, so it is greater than 0. So now to write my answer, please don't forget to do this part. So you have two spots where this was true. So we can say negative infinity to negative 1 and 3 to infinity. Or you can use set notation, x such that x is less than negative 1 and x is greater than 3. However you guys want to write it, interval or set notation, that is completely up to you. All right, now this last one that we're going to do, and if any of you are dying to see number or letter D, I am happy to do, or sorry, E. I am happy to do letter E with you in class. All right, let me move this over so I don't have to erase that work. Okay, so I'm going to look at both the numerator and the denominator. So the denominator gives me my undefined values, where my numerator gives me my x-intercepts. So I'm going to start with that. X minus 2 squared equals 0. So this is just x equals 2. And then the denominator, x squared minus 1 equals 0. I add the 1 over, so x squared equals 1. So x cannot equal plus or minus 1. So don't forget, these are your vertical asymptotes. So that's what x can't equal. So I'm going to make my number line. I have negative 1, 1, and 2. So now let's talk open and closed circles. The numerator when you're looking at the numerator, you pay attention to the sign of the inequality that you're given. Since it is greater than or equal to 0, you actually get a closed circle for the 2. Now on the denominator, we need to remember the denominator always gets open circle because that is your vertical asymptote. And now I just have to test points. So I'm going to test -2. I'm going to test 0. Oh man, I'm going to test, let me write these in a different color. It's got a lot that we have going on here. -2, 0. Sorry, hate to do this to you guys, but 1.5, and then 3. Again, you need to make sure you guys remember that you don't just skip the in between the 1 and the 2 because you see, oh, that's a fraction, and I don't want to deal with that. Don't be lazy. So I have x minus 2 squared, so -2 minus 2 squared over -2 squared minus 1. And it has to be greater than or equal to 0. So the top gives me -4, and -4 squared is 16. This gives me 4 minus 1, which is 3. I don't even care what that equals. I just know that that is greater than 0. That is absolutely true. So I'm ready to move on to the next one. 0 minus 2 squared over 0 minus 1 has to be greater than or equal to 0. Well, 0 minus 2 is -2, and -2 squared is 4. 0 minus 1 is -1. Is that greater than or equal to 0? Nope, because that's going to give you a negative number. Now for this next one, with it being the 1.5, I am going to go ahead and just use a decimal. 1.5 minus 2 squared over 1.5 minus 1, and it has to be greater than or equal to 0. So I know that this is true just looking at this. Even though this gives me a negative, when I square it, it becomes positive, and 1.5 minus 1 is a positive, and a positive over a positive is greater than 0. But 1.5 minus 2 is -0.5. And when you square that, you get 1/4, so 0.25 over 1.5 minus 1 is 0.5. Is that greater than or equal to 0? Yes. As soon as I see that I don't have any negatives left, I know for certain that that is greater than 0. Okay, now I'm on to my last section to test. 3 minus 2 squared over 3 minus 1. 3 minus 2 is 1. 1 squared is 1. 3 minus 1 is 2. Is 1/2 greater than 0? Yes. So I had 3 sections where this was true. But notice how in this right piece you do have this solid dot there. So I actually am only going to write my answer using 2 intervals. So my first interval is this side where it's -infinity to -1. And then it takes a leap all the way over to the 1. And it goes, open or closed circle, so that's okay. It keeps going to infinity. Or you can write this as x is less than -1 and x is greater than 1. So set or interval notation, either one is fine with me. So you're going to practice this a lot tomorrow in class. Whatever questions you have, please make sure you do bring them with you. If you're not sure where something is coming from, write that down and make sure to get my attention on that tomorrow while you guys are working on your classwork. Or when I'm going over this again in class with you, make sure you remember to ask. All right, see you tomorrow.